1.7, solving inequalities in one variable. For this section, we're going to solve inequalities, graph the solution set on a number line, and write the solution in interval notation. Solving inequalities is similar to solving an equation. However, there are differences. One difference is that we don't have an equal sign, we have an inequality symbol. Also, when we divide both sides of an inequality by a negative number, or when we multiply both sides of an inequality by a negative number, we have to change the direction of the inequality. You will see that in the first example. So this is the first example, and what I did is I subtracted 3x from both sides and I also added 6. We combine like terms, and then to get x by itself, we divide by -2 on both sides. Since I divided by a negative number, I have to change the inequality, so it flips. This is my solution. To graph the solution set on a number line, we shade to the left because those are all the numbers that are less than -11/2, and you have to use a bracket because we have to include -11/2 since we have the equal. And interval notation follows from the number line. You start with writing the smallest to the largest. So this continues forever, so it's -infinity, always parenthesis, and then comma, go up to -11/2 and use a bracket. Let's take a look at the second example. Since we have fractions, we need to eliminate them. Multiply both sides by 6. That is the common denominator. Two goes into 6 3 times. Use parentheses because you have to distribute in the next step. 3 goes into 6 twice, so 2x times 2. Distribute. In order to solve, subtract 3x from both sides. Six is less than x. This is solved. It's also written backwards, so you got to be a little bit careful. Usually x is written on the left, not the right. But if it's written like this, you can still graph it. Just read it carefully. It says that x is bigger than 6. Anything bigger than 6 would be on the right. Shade to the right. There is no equal, so we have to use a parenthesis. And then interval notation follows from this number line. Remember, smallest first, followed by largest. 6, +infinity. Let's take a look at two other examples. These are different because although they are inequalities, they have 2 inequality symbols instead of 1. So if you see a situation like C or D, what we have to do is we have to isolate x in the middle. So to get x by itself for C, subtract 2 from all 3 sides, like this. Zero is less than -x is less than 4. This is essentially solved, but I want positive x, not negative. So in order to make this positive, we're going to divide everything through by -1. And again, since you're dividing by a negative number for this inequality, we have to change the direction of both inequalities. 0 divided by negative 1 is 0. Change the direction. Change the direction. This is solved. It looks like it's backwards, so if you don't like it this way, if it's confusing, rewrite it. You can write it as negative 4 is less than x is less than 0. These two are equivalent. To graph this on a number line, it's really quick. We basically shade between negative 4 and 0. Those are the values that work. Use parentheses because we don't have the equal. And interval notation follows negative 4, 0. Let's look at the last example here. So this one, we have to isolate x in the middle. Add 3 plus 3 plus 3 plus 3. 6 is greater than or equal to 4x is greater than or equal to 2. Now what we want to do is divide by 4. I don't have to flip the inequality because we are dividing by a positive number. We want to reduce 3 over 2 is greater than or equal to x is greater than or equal to 1/2. This is solved. Again, this is backwards. If you want to write it this way, we can. And again, remember, the smallest number is always first. And for that type of a problem, you always shade in between. Since we have equal for both, use a bracket. Interval notation follows from this graph. Bracket 1/2, comma, 3 over 2 bracket.